welcome everybody. Welcome to Microsoft Build, and welcome to this session on Azure Functions for Java. So it's a Ask the Team session, so it's a question and answers. So you will need to participate if you want some good session. It's about Azure Functions, so we'll talk about serverless, and for Java. So we'll of course talk about our favorite language. And by the way, today is Java's 25th birthday, so happy birthday, Java. I hope we will be all able to share together. The agenda for this session, first of all, what to expect. So this is the current slides. I'm just going to tell you a little bit how this works. Then I will introduce you, to the team. And then we will have the core of that session, which is questions and answers. And we will have, of course, some closing thoughts. So the most important thing today is to answer your questions. So please use the chat box to ask questions. There's a chat box next to that presentation video. You can either post anonymously or use your name. Your questions will appear once approved. There is a moderator panel for that session. You can upvote your favorite questions using a thumb up. So please upvote the questions that you like. That's how we will get some quality questions. We will, of course, answer you verbally. And we'll answer the most popular questions first, and that's why it's important to upvote the questions that you like. There is some etiquette for this session. First of all, it will be recorded. We've got two moderators today. So we've got Christopher Maneux and Maud Levy, who are from the developer advocacy team at Microsoft. So please help them. Don't spam the chat. You know, if you've seen the questions once, don't put it again. Please upvote. And you will please need to adhere to the Microsoft Code of Conduct. So if you have registered, you probably already agreed to follow this. Basically, we will not tolerate any harassment or discrimination. And if you have any concerns, any issue, well, please contact our hotline, and we'll take this, of course, very, very seriously. It's very important for us. Now, please let me introduce you to the team. So Jeff, can you introduce yourself?
Yeah, sure. Hello, everyone. Thank you so much for joining. I'm thrilled to be here today with all of you. So I'm Jeff Holland. As it says, I'm a principal PM for Azure Functions. And so I'm working day to day with our engineers across the world who are building the product as a product manager. So thrilled to be here to talk specifically about Java. Julian, I had no idea it was a celebration day as well when we got this scheduled too. So it's very fitting. But please, yeah, as was mentioned, if you have any questions, anything you want to discuss around serverless Java, please pop that into the question and answer box, and we'll get to it in just a moment.
Yeah, then second person is me. So I'm the person who did the introduction. So I'm Julien Dubois. I'm a cloud developer advocate at Microsoft. I focus on Java. That's why I'm celebrating. There's a little Duke behind me, if you can see it, but it's a bit small. And you can follow me on Twitter at Julien Dubois. Of course, I am focusing on Java, and part of the job is working on Azure Functions for Java. And our next speaker is our guest star from today. Is not from Microsoft. It's Graham Rocher. So Graham, I'll let you introduce yourself.
Hello, pleasure to be here. Excited to be here. My name is Graham Rocher. I'm the creator of a couple of popular frameworks in the Java ecosystem, Grails, and most recently Micronauts, which has some interesting aspects when it comes to Azure Functions. So really excited to be here and to join in the celebrations on 25 years of Java.
Okay, thank you. So that was all about the introductions. Now we are going to start the questions and answers. So if you want this to be a good session, please ask your questions. You can ask us, of course, about, let's say, generic questions about Azure Functions, like best practices, tips, or the roadmap. So Jeff is the best person for the roadmap, as is the PM for all Azure Functions. So it's really a good time to ask questions about roadmaps. And of course, if you have questions about Micronauts support on Azure Functions, which was announced, I think it's on it was last Friday, Graham.
Yeah, absolutely. It was pretty recently, I think.
Yes.
No more than a couple of weeks ago. So
yes.
It was hot off the press, and we're thrilled to be able to support Azure Functions for the Micronaut user community, and provide yet another option for the serverless support that we have, which is pretty cool.
Yeah. So that's what, yeah, and basically that's the whole idea why we invited you. It was we did it in a very short time, but I think it was a good timing that you just announced it, and we've got built today, so we can, well, all celebrate and discuss about this together. So do we already have some questions?
We have one question. Question is on Java, and so the question is, when will higher Java versions be supported?
Yeah. I guess that's for you, Jeff.
Yes, I was going to say a roadmap one, so that's perfect. Yeah, so we're actually well underway right now for Java 11, which will be the next one to be supported. So right now, as the questioner probably knows, we have Java 8 in production. So usually when you're using kind of our in-the-box languages, and that's not getting to some of the custom handler stuff that I think even Graham will be talking about here in a bit. But if you're just using in-the-box stuff, Java 8 is what we have. We've started work on Java 11 that will be coming out. I don't want to commit too much, but coming out in the coming weeks, coming months. So keep an eye out for Java 11, and then we'll continue to move on. Those LTS versions is our plan for what we'll be supporting as kind of in the box languages.
Yeah, that's a question that comes very often. You know, I maintain the sample apps for Azure Functions for Java, and like it's a 9 questions out of 10 is I want Java 11. Then, of course, we have a strong commitment to LTS support, and it's of course complicated to get always the latest versions.
Yeah, makes sense. Yes, you see the latest and greatest. You watch someone do a demo with Java 11, you're like, I want to do that too. So I get it. And yeah, in general too, I would say as a team, we've gotten a lot better, a lot faster at being able to keep up with these languages and having the lead time between when, you know, a Java 15 or Java 14 or whatever gets released to when we can fully support it. So Java 11 should be coming pretty quickly, and we expect to be able to keep up pretty quickly after that as well.
So we've got another question.
Yeah, so we have a question from Maya. She's hoping to code using Java directly on the Azure portal. Is there a roadmap like this? And if no or yes, is there other way to actually code in your Azure function in Java in your browser?
Yeah, so I'll take a stab at this one too. And this is always where I want to be thoughtful because I want to be very open, but I don't want to overcommit here. So I'll start with some background, I guess. If you're going and writing like a JavaScript function today, what Maya is kind of showcasing is that I can do that all from portal.azure.com. I can create the function, and I even get a little text editor in there to start authoring the code. It's not a whole lot. The experience isn't fantastic. It feels, I often say it feels a little bit like using Notepad to write a JavaScript function, but it's something. And especially when you're making quick edits or trying to get started, it's super nice to have. We don't have that for Java today. I would say the primary reason we don't have it is we don't have portal support for any compiled languages. We only have support for some scripting languages because we don't have a great way to do the compilation task in the portal-driven way right now. In terms of roadmap, I guess I would say what's possible now that I would encourage folks to look at that I actually personally have used recently is this new code spaces stuff that's been announced. So with Visual Studio Code Spaces, you can spin up a dev environment very quickly in the portal, but it's a fully featured dev environment. And so we have a sample where you can spin up a code space that is the Azure Functions tooling. It's the Java tooling. Now in the portal, you don't have to do any of the install stuff, great for quick edits, but it works in the portal. And so some of the work that we're doing right now, and what I will share is that we're looking at code spaces, we're looking at the portal experiences, and we're figuring out how can we make that easier for folks to get these set up side by side to get that quick development experience. So today we don't have anything out of the box. Understand the desire for it. I would check out code spaces in the meantime, and it is an area that we're investigating to figure out how we can weave deeper into that experience.
Yeah, I believe code spaces will indeed be the long-term answer. By the way, I had the same question on code spaces last week. Code spaces is being released with Java 8 by default. So I had the same question as the one you got before. When will we have Java 11? And you can bring your own Docker image. So, but of course it's not the same level of support, but you can.
Did they have an answer to the other one? I know this is like when Java 11 will be out of the box without doing the custom image.
Yeah, I think it's just because it takes the default Java version coming. Yes.
Sure.
So I have another question. What is the current call start time for Java function? Does using a framework, Spring Boot, Microsoft, or Quarkus, add a lot of overheads?
Yeah, this is also for you, Jeff, I guess. I got some stuff on this. Well, for everybody.
You can give it a shot too, and then I can add in some context or color. So Julie, why don't you go ahead and you can give your initial observation.
So my own observation, because I'm not the PM, so it's just as a user. When I do a call start, and I did it in a demo last week, so it took me basically 3 seconds to get a VM. And then, so I'm using Spring. So with Graham, we can have a look at Micronauts. It took me between 3 and 4 seconds for Spring to start. So in total, it was like 6 or 7 seconds to have everything. Then it's just, end user observation. And maybe I got lucky, maybe I was unlucky. You never know how it works. So it's just a normal user observation. So I don't know. Jeff, if you have something more realistic.
Yeah, and I would put you right based on the numbers that you just said. I would put you right around what I would expect for the average to be for Java right now when completely cold, meaning you haven't executed in over 20 minutes, and so we've scaled you all the way down to 0. I'll share kind of what's happening behind the scenes, because that might also even help with where startup times might increase a little bit. So obviously, we don't want to go as far from saying like, hey, Jeff hasn't hit his function in 20 minutes. So let's say file new VM, wait for the VM to start up, and then install the right tools and everything else and do everything till that request finally hits a warm function. That would take upwards of like 45 seconds. And so we do a bunch of optimizations behind the scenes to try to make this number as small as possible. So if I'm using Java 8 today, and I have my code, what will end up happening is the request lands on our, event source, the front end. If it's HTTP, we'll notice there's a queue message, whatever else, and we'll kind of realize, hey, Jeff's function isn't running anywhere over here in this cloud. We need to hurry and spin one up and make it warm. And we have a huge pool of what we call pre-warmed or placeholder function containers, which are containers that are general purpose, but they're already running the functions tooling. They already actually have Java 8 running. And so we've already kind of started the Java process. It's running there. It's a kind of an idle process. It doesn't have your code in it yet. But a lot of the startups cost, we try to pay ahead of time. So like the gRPC channels, everything that we can, we try to spin up. So we grab one of those general purpose ones that's already partially warm. And then all we have to do is take your code file and quickly mount it onto that image, because your code will be unique. That code gets mounted on. We do some pretty interesting stuff behind the scenes where when you publish a Java app, you publish it as a zip or a jar. We don't even unzip it if you publish a zip file. We just mount it directly on and we read from the zip. It's some pretty crazy technology that I couldn't explain to you how it works, but it gives us a little bit more time where we don't have to wait for an extract step. The code recognizes that there's a new environment, kind of a new code there, and then it gets going pretty quickly. So all said, for Java, that takes about 3 seconds. If you're using other aspects like the custom handler feature, it really depends. Or even if you're using things inside of your app where maybe you're starting up additional capabilities, you're pulling in external libraries, be it Spring or otherwise, you'll want to be aware of like how much overhead does starting that code up, starting that library up, starting that binary up take. And that will all influence kind of that time. But in general, right now, globally, it hovers around 2 to 3 seconds. I get a report every day. So it varies, but that would kind of be the number that I would share. And then some of the optimizations we make in considerations, if you're seeing that number be longer, thinking about what might be happening in that little package that you're giving us or in those binaries you're telling us to run that might make that number even larger.
And to answer the framework question, in terms of do they add overhead? Does Spring, does Quarkus, does Micronaut add overhead? Each of them, yes, have a little bit of overhead, and it varies depending on the framework that you choose. So I would say Quarkus and Micronaut are different to Spring in that a lot of pre-computation and compilation time stuff or magic happens to ensure that the application is already computed and ready to execute and start a lot faster. Spring's use of runtime reflection does add more overhead than Micronaut or Quarkus. Now the cold starts, I can also pretty much echo what has been mentioned here about the timings of how things how long things take. For Micronaut, you're looking at probably 100 milliseconds additional in terms of the framework overhead, and then but with that you get all the benefits of dependency injection, AOP, structuring your application, reusing Micronaut components like the HTTP client and so forth. And a lot of the users find that really beneficial. Now, as for cold starts themselves, it's only a problem for certain types of functions, right? If you're writing background functions or asynchronous functions or functions that don't require an immediate user response, then it's really not a big deal that it takes a few seconds to spin up. Because it's only really a problem in the HTTP function space. If you're, say, for example, want your function to respond to an HTTP request as quickly as possible. And in that space with Java, there's a lot of innovation happening, a lot of new developments in the Java ecosystem. Particularly, and one interesting option, for example, would be adding a custom handler for Azure that uses GraalVM native image to execute your functions. So that's an area we're looking at and exploring on the Micronaut side. We already have that working for several serverless platforms, and it's proven very effective in effectively eliminating the cold start problem, if you want.
Okay, there are a couple of questions that just popped up. So how can I access resources in my VNet from functions, if that's possible? So this is a question by Surendra.
Yep, thanks, Surendra. I'll take this one quickly too. So today we do have the ability to let you access this in a VNet, but you do have to select a specific plan type. So for functions, the one I would recommend looking at first is what's called the Functions Premium plan. It's more or less the same as a function consumption plan in terms of the tooling and the portal interface and everything else that you would be looking at. However, as the name would give you the notion of, it's premium in that it gives you a few additional features, but there's also a bit of a cost implication. And so one of the other things that comes along with premium is actually the ability, or in many ways the requirement, that you won't have cold start. And so with the premium plan, we keep at least one of your apps warm, ready to receive requests all of the time. But there's also a cost implication there. That's part of the reason it works great in a VNet too, because we can just keep that running connected to your VNet, ready for the next request. And so that even if you have resources that need to connect to a VNet, you're not paying a huge tax for additional latency to make that VNet connection. So it's possible today, but you will need to select a specific plan type that supports VNet. I think the primary one is the Azure Functions Premium plan. You can go all the way to what's called the app service environment. But in many ways, that's like taking a corner of a data center and saying these 10 or 20 or 100 virtual machines are my isolated special virtual machines in my VNet. Nobody else can touch them. I'm going to be paying for them completely. So that also lets you do VNet, but it's a different type of scenario. So Azure Functions Premium Plan hopefully will give you what you need for that VNet connectivity, inbound or outbound.
We have actually two other questions that are kind of related, and I think both of them are for you, Jeff. It's about feature parity between Azure Function supported languages. Mike asked, for example, recently he was building a function in Java and was trying to access the function directory via the execution context, but it's only available in C# and not in Java. Any plans to make feature like this have a parity? And another anonymous viewer asked about the approximate time that a new feature like custom handlers take to the Java world, and do you have some insight to share about why there is a delay between different languages, and can we assume that all features coming to the Azure function will be supported in a Java?
Yeah, a lot of good stuff there, and I'll take a chance, and then Graham, I'll probably even pass it over to you as we go into custom handlers a little bit, so you can even give your perspective as you were kind of alluding to at the beginning as well. But let's just talk about feature parity in general. I think there's a few pivots to this that are important to address. So the first one is just some underlying feature parity between languages. The example that was brought up was it's actually not even unique to C#. In functions in general, if you want to pull in a file from the functions directory, we'll pass in this execution context, and we have a method to say get the current environment path or whatever else, so that you can just relative go off of that and pull in whatever files, JSON or otherwise, that you might have included in your deployment. There is a bug, or was a bug, is what I was hoping to say. I do remember managing this, a few weeks back now. It's been a while, where we just had a gap in the Java library for whatever reason that wasn't getting surfaced up in some of the versions of the Java library, just that execution thing. There was nothing technically preventing us from surfacing it. It just wasn't being bubbled up. I almost would mark that more as a bug than a feature gap. However, I do, this is a reminder that I want to go make sure that was closed, because that one's more just us. We need to make sure that that's not an issue there. It happens to work for Python, for JavaScript, for whatever else, including C# today. So that's kind of one class, which is hopefully if there's something at more of a library level that we can do, we'd want to do. Moving up, though, we also have some features that we just want to do a better job giving parity all up. So I will say for my team over the next 6 months, 8 months even, this is going to be a big focus to make sure that regardless of the language that you choose, you get a really rich experience. And so this isn't necessarily anything you're missing out on, but if you're maybe using, I'll give you an example that I hear that comes up a lot from Java users, which is I'm using a service bus queue triggered function. So I'm going to be triggering on a queue, and I want to be able to do some gestures on that queue message. So if you've used queues before, you'll be familiar with concepts of dead lettering a message, or abandoning a message, or completing a message. These are all things that you want to do with a service bus message. In C# today, because of how C# is run, it's nothing that we like C# more about it. It's more from an architecture perspective of how some of the things are wired up. If you look at some of the documentation or samples, you might see something where you trigger on a message and we give you the C# SDK directly to say message.complete, message.abandon, message.deadletter. We call this rich triggers or rich bindings, where we inject in the C# Azure SDK directly into your code just to make it a little bit easier to do some of those advanced gestures. Any language outside of C# today, we don't offer that yet. It's, as I mentioned, it's kind of more of a technical reason. We're jumping across processes. We're jumping across a bunch of stuff. However, that is something that we want to make first class for every language. So there's nothing you can't do in a Java function that you can do in a C# one. But today it might require writing a little bit more code. You might have to write the code to pull in the service bus SDK in my example to do that checkpoint and dead letter, whereas in C#, it gets passed in for you. But I'm not happy with that. I'm not satisfied with that. I realize there's technical challenges, but our team wants to make every language feel native and get some of those delightful features as well. So I would say kind of roadmap wise, that is a huge focus. One of the top priorities for our team moving through the rest of this calendar year is closing some of those technical gaps, making it so that other languages feel and get all of the same features across the board. And so I realize there's some gaps today, but not something that we're satisfied with right now. There's some good reasons why it's that way, but we'll continue to close them. And then I think in general, I know there was a lot to the question in terms of what languages are porting or how which ones. Before we go over to custom handlers, I'd say like for Java 11, that's a great example. Like why is there not Java 11 as a quick start? I want to do a new function today. And there's a few things at play. The first is that for those out of the box languages, we want to make sure that as a team that we have done everything we can to optimize performance, but also to make very supportable. So when we ship a language out of the box and you might hit an issue or a bug and you create an Azure support ticket or you file an issue on GitHub, we need to make sure that our team is staffed and capable and ready to go and respond with that special language. So what we're doing right now with Java 11, like obviously a little bit of the work is just versioning the libraries, versioning our stuff to make sure that it's compatible with Java 11 if there's breaks or optimizations we can make. But then we're spending a ton of time on performance, making sure that I kind of mentioned before, we actually load a lot of this stuff in advance. We pre-warm it. We need to make sure that all of our infrastructure knows how to pre-warm Java 11. And so that when you choose Java 11, things are ready to go. And then finally, just making sure that all of the code tooling and that our team is ready to manage support requests so that when we click that light, when that thing goes into production, that we're ready to service it. So that's some of what's happening behind the scenes on why it does take us sometimes a few weeks to build support for a new language. But that said, I think kind of where this question ended up going to is we do have some features like custom handlers, which we've alluded to today. We haven't actually defined yet, I think, what that is. And maybe Graham, I'll just pass it over to you. I don't know if you have any thoughts on kind of custom handler, because you mentioned, especially for Grail, is something that you've been looking at with your team to helping light up.
Yeah, for Micronauts in particular, we have support for computing essentially native images with Graal VM, and the advantage of a native image is obviously that it starts significantly faster because you don't have a virtual machine, and you're much closer to the actual hardware and so forth. So custom handlers is I believe and correct me if I'm wrong, I believe it's a preview feature right now in Azure Function.
Yep, that's right.
What that allows you to do is essentially create a native executable, and it has to be a kind of Windows executable, I believe, and it must listen on a certain port that's specified by an environment variable and so forth. But essentially, in essence, it allows you to build a function that is executed natively on the native hardware. So we can do that for Java applications using Graal VM native image to compute those native images. There is a little bit of overhead in terms of tooling, because more in terms of CI, and it would be interesting actually if this would be something that Azure, the platform, would offer to Java users in the future, is essentially the ability to build a Java function into a native executable. That's certainly an interesting possibility for the platform to offer in the future. But in the short term, what users can do is build a regular Micronaut application into a native Windows executable, and essentially run that. I believe the custom handler support, you have to provide a JSON file which points to where the executable lives and so forth, and specify the environment variable that it has to listen to on the port. And with that, you'll get an application, a function that starts up extremely fast, being native, and is able to serve requests, HTTP correct requests much quicker, greatly alleviating the cold start issue, which is an issue for some users. Being native as well, you will also, another benefits of going native is the saving in terms of memory consumption. So a native image constructed with GraalVM will typically use, in memory in terms of the tens of megabytes, rather than when you run the virtual machine in Java, which typically will always use at least a couple of 100 megabytes.
Thank you. And now we have a question around Spring Cloud Functions. It's a question by Andy, who is wondering if there are any limitations in current Spring Cloud Functions, maybe performance-wise, and he wants to know if you could please detail this.
Yeah, so I think it's for me as well, because I maintain the example project for using Spring Cloud Functions on Azure Function. I don't think there's well, there are some limitations, but which are not tied to Azure Functions. For example, I had it was actually a bug. I had a question last week. Somebody wanted to use Spring Security, and Spring Security uses servlets. It's a servlet filter. Well, on Azure Functions, you don't have servlet filters, so of course that doesn't work. So there are some, let's say, there might be some libraries in the Spring ecosystem that will not work, but most of them, like if you want to do Spring Data or anything else, all of them work. So for me, there is not a lot of limitations in terms of features or ecosystem. In terms of performance, we talked about performance earlier, and when I said it was starting like 3 seconds, it's I would say a simple hello world. Of course, if you add, I don't know, Hibernate, GPA, if you add tons of stuff, of course it will be slower. Maybe GraalVM would be a solution for that, or maybe another framework like Micronauts would also be a solution for that. But I would say with any Spring application, the more features you add, the slower it would get, especially if you add something like Hibernate. So I'm a huge Hibernate fan, but of course it takes some time to start up. And so for a function, it might not be the best solution if you want to avoid the cold start issues. But yeah, otherwise, yeah. So I wouldn't say there's a lot of limitations in terms of features, and in terms of performance, it would be I would say things that you would expect. And also for a function, if you add, I don't know, 10 different libraries, it's a bit weird for a functions. Maybe it's not a good function, but that's another discussion. So yeah, not a lot of issues for me.
Great, thank you, Julien. We have another question for Jeff, and I don't know he will be able to answer that one actually. It's from an anonymous watcher. Can you give us an approximation of how many users are using as a function in Java versus the other languages, or any interesting statistics about Azure Functions?
Yeah. Let me share. I have to be careful here on a public stage to make sure I don't overshare what I can't. But definitely, I actually saw that question pop in, and I just opened up my daily report of languages even to give a sense. So what I will share, let's see. So unfortunately today, Java is not the most popular language in functions all up. Part of that is because it's one of the newer languages. We've only had support for Java in the last 2 years, and for things like C# or even JavaScript, we've had support for over 4 years now. But that said, it's actually a very healthy subset of our other languages. In fact, in general, there's a pretty even split. We see some competition depending on how new a language is to become bigger or smaller, but Java is already a substantial slice. I guess that's as specific as I'll get, but I will say a few interesting things about Java to note. For one, it's growing very quickly, and it's our third fastest growing language right now, just in terms of how much it's growing every month, which again, there's kind of some caveats there in terms of how new it is based on some other ones. What I will mention though about Java that I can share, what really excites me about Java and the types of usage that it's done, and I think even just a testament to the fact that Java is used in so many enterprises, is that if I look at the statistic of the amount of individual subscriptions who are using Java and the amount of executions that are coming from Java functions, Java has an incredible ratio there that blows out of the water other languages like Python and JavaScript. So we might get a lot of folks who are kind of using JavaScript functions and playing around with things in the portal or building APIs. The Java users who are using functions, a big portion of them are doing billions of executions every single month. And that's not something that we see at the same ratio of like user to billion executions that we do with Java. And in large part, it's just because of the caliber of users that are leveraging Java, the types of scenarios. So I guess what I would say is that Java is a healthy leader in the pack around executions all up, especially when you pivot with the executions and number of users. It's also very healthily growing. I'm really pleased with the response that we've had over the last 18 months or so when Java has been generally available. So we're seeing healthy uptake there, a growing community, a growing set of tools between Spring, between this Micronaut tooling. So I think that's some of the stuff that I'm able to share in a public forum. Hopefully that at least gives you the sense. And I think there's even a few published use cases as well, where you can see the type of customers that I'm alluding to of how they are using Azure Functions in general. So for example, I remember at the Spring One conference, a seer who was from the Microsoft team, as well as some members from Best Buy, gave a presentation about using both Spring and Azure Functions to build some of their capabilities. Fantastic presentation that's online as well. So that's some stuff, hopefully, to give you a sense for the type of adoption and the growth that we're seeing without me giving away more than I'm able.
Yeah, let me just jump in on this one also. Just to confirm what you said, I work with a few customers. Well, there's one with literally doing billions of requests on Azure Functions, and indeed that's very different to the kind of people that are using Azure Functions when they're doing it on Node.js. I mean, in other languages. I don't know if that's public or not, and I am breaking the rules because Christopher is supposed to ask the questions, but Christopher, you will know if that customer is public because he was supposed to speak at Serverless Day, which is another conference which has just been cancelled because of the virus.
Yeah, so, but I'm not sure we can say the name out loud yet.
So we will not say the name. But there is another very big customer in France, and he was supposed to talk publicly, but because of the virus, is not doing it. But yeah, just to confirm, yeah, in Java we've got a population which is very, very different to the population that you would have in other languages. Where I would say we'll have probably fewer companies, but companies who are doing workloads which are a lot easier than in other ecosystems.
Thank you, Julien and Jeff. I'm going to ask you another question. You can choose to run the JVM on Linux and Windows. What are the advantages of each?
Yes, and I'm even open to others on the call too, across just in general. So we do, in terms of like benefits of Java on one of those. I would say for other languages, like if I take Python, for example, Python has a whole bunch of native dependencies that people are pulling in. It's also not running in its own JVM type thing. And so very often for like a Python user, when they see that choice of, oh, I could do this on Windows or Linux, it's a lot more obvious to them. They're like, oh, I'm developing on a Linux machine or I'm using Linux libraries. I want the Linux flavor. With Java, at least from my experience, I don't see as much of that. There's definitely kind of some like initial I love Windows or I love Linux thinking in there, but I think a lot of how Java works it's able to make it so that whether it's on Windows or Linux, like Java runs everywhere, so it's just fine. And so for the most part, you don't have to worry a whole lot about which one of those choices you choose. It is an option for you. Where this does come into play, though, and I even saw there's a question that maybe we'll get to later around some of the containers or Kubernetes-y stuff. So specifically, if you use the Azure Functions premium plan, we give you the ability, if you want to publish your app in a container, instead of giving us that code zip file or that jar that we kind of alluded to as well. So you can give us any functions container that has our runtime in it, and we will run it for you. There's a number of organizations, for whatever reason, that are like, hey, we actually prefer that container approach. We want the whatever benefits, portability, consistency, custom control over system dependencies that containers bring. And so we actually are going to have our work stream go into that route. That one, that becomes a lot easier. It's, that has to be Linux. We're going to be using Docker in Linux to be running those behind the scenes in the cloud. So other than that, I would say kind of whatever you feel like choosing. I usually just leave it as the default, which right now is running on some Windows systems behind the scenes, because at least for the apps that I've been working with, that hasn't been a problem. But I'd even be curious, Julian or Graham, or even others on the call, if there's considerations in general for Java on Windows or Linux, because in essence, those would apply the same. But as I mentioned, I haven't seen a whole bunch just in terms of how Java works that would force me to go one way or the other.
Yeah, let me just answer quickly on this, because I'm a culprit of it, in fact, because when we discussed about using, having Linux and Windows on Java, I had some feedback from our big French customer, and what they are doing, and it's very specific. So I'm not sure it's good for the majority of people, but what they are doing is that they are using a specific native library that only works on Linux, and they call it from Java. So those people who have a very specific use case, and I'm not even sure it's a good use case, but well, those people, they needed Linux support for Java functions. So they're big customers. It's a legitimate usage, even if that's something I would like to delve a little bit into, because I'm not sure this couldn't have worked on Windows, but well. We do have customers who want to run the Java workload specifically on Linux, and it's a little bit my fault if I push that.
Yeah, it's perfect. I'm glad you actually gave that perspective, because I think that aligns with like, hey, if you have a reason to run Linux or you prefer to run Linux, it's there's an option and there's no downside to it. So like, go party on the Linux flavor of stuff too. Happy to support you. It's not like you're going to be trading off one thing or another around performance to do that.
Yeah, it was, yes, they were using a native library, which is important for network performance. So they would have had better network performance doing that. So we support our customers, of course. I don't know, by the way, Graham, I have a question for both of you. Again, I'm bending the rules, but Graham said he was going to build a native image for Windows. Can't he build native image for Linux? Do we support that? Honestly, I have no idea. It's a question for both of you, basically. Do we have GraalVM support on Linux also?
So I think for Linux, you may need to use a Docker image.
Oh yes, sorry.
As far as I understand. So it could be done. We could build a native image for Linux running inside of a Docker image. But that may add a little bit of overhead to the cold start. I think if you're going to get the fastest cold start, it may be better to build a native Windows executable, but it's worth exploring both approaches, I imagine.
Yeah, okay, so that's interesting. Indeed, okay, so you will have better cold start with Windows than Linux. That's very interesting.
Yes, I believe so. A lot of this is theory that we have to get to.
So actually, we have a couple of questions regarding Micronauts, and the first one is, can you describe how Micronauts supports for Azure Function works?
Sure. Okay. So in our experience with building support for serverless on a variety of different platforms, there's typically two types of user that wants to use a FAS or a function as a service platform. One approach is to take to work with the low-level API provided by the function as a service platform. In this case, Azure Functions for Java has its own API where you can specify the event or the trigger essentially that you want to listen for to invoke your function. So we support that with Micronauts Azure support for Azure Function, and the way that works is you subclass this superclass. I think it's in an io.micronaut.azure package, but it's something called like Azure Function. You subclass it, and what happens is when your function is instantiated, we dependency inject your function and wire in the services that are required by the function when the function is initialized. So that allows you to build like the first use case, which is like low-level functions, so background functions, functions that listen for blob store events, or that those kinds of functions essentially. Another common thing that many users that come to something like Micronaut are looking at is they have an existing Micronaut application, that's structured like a traditional a non-serverless application that runs as a server. So you have like controllers, web controllers, and they want to take just like a slice of that application and they want to deploy it as a function. So this is like, and that approach is a bit harder for a lot of folks because it's often like you have to go the full serverless function route or you don't. And what we've done for all the serverless platforms is allow you to take an existing kind of Micronaut application that's structured like a regular application and say, I want to deploy just this part of the application as a serverless function. That way you can continue developing a regular Micronaut application and deploy just the parts that you want to, which are maybe like infrequently used or fit the serverless model or whatever it may be, deploy those to Azure Function as a slice. And that's a very popular approach with Micronaut, and we provide support for that. You can essentially use all of the regular @controller and @get annotations to structure your application like a regular normal application. And then we provide an implementation of an HTTP trigger for Azure that essentially routes the incoming Azure request to your controller and action and so forth. And that's proving very popular, and that has proven popular on a variety of different serverless platforms that we support. The interesting thing that Micronaut provides when you go that model as well is that you can take the same application and deploy it to all the popular service providers without necessarily using kind of API specific provider specific APIs. So it's a general abstraction over that, and I think that's an interesting approach that people find compelling as well. But obviously, we don't want to take away the power of the underlying Azure Function API. So we allow users to use the low-level API as well and directly define triggers, directly inject, for example, the execution context and get hold of the logger and all of the regular things that Azure Function users are used to doing.
Thank you. And we have another question for you, Graham. Question is, do we have access to the full Micronaut APIs or only to a subset?
You have access to all of the Micronaut APIs. So you can use Micronaut data. You can use Micronaut's HTTP client. Whatever makes sense for your application is available at gRPC client if you want. all of it can be injected into an Azure function, either a low-level function, or you can, like I said, you can structure your application as a regular Micronaut application and deploy just a slice. Speaking of that approach, we recently launched a Micronaut launch, which you can go to micronaut.io/launch, which is like a project generator, and it has a React-based front end, essentially a static website front end, and the back end for it, which generates Micronaut applications, can be deployed to Azure Function as a serverless application. So it's a good example of using Micronaut to deploy to Azure, and that same backend can also be deployed to a variety of other different serverless platforms, and also run as a regular netty or servlet application. So you can take the same application, deploy it to Azure Function, deploy it as a servlet, deploy it as a regular netty application to a Docker container, and provides you with a lot of flexibility to how you would structure your application.
And we are 9 minutes left in this Q&A session, and we still have a bunch of questions for you guys. One of them about KIDA project. Can you give us some roadmap for KIDA? How and where do you see it growing apart from adding more scalars to different systems? And the question was directed to Jeff, but if any other people have something to add, do not hesitate. Jeff?
Sure. Yep. And so for context too, for people who might not be familiar with the project, just to kind of level set, and then I'll answer the question. One of the things we want to provide is tooling and support and the ability for you to take event-driven serverless functions and run them everywhere. And so that includes in our cloud and that consumption or premium SKU where you're using code or container and doing the serverless thing. But we also have users who are like, hey, I have some workloads that for compliance reasons, for personal preference reasons, for IoT edge reasons, we actually want to run elsewhere, either on premises or maybe even in other clouds. And so we have been working on a few pieces of tooling that allow you to take those functions in a container, but run them anywhere, ideally with the same productive dev experience where you just kind of pop open into IntelliJ or VS Code or Eclipse or whatever. You write your function and then you say, hey, go run this thing serverlessly, but maybe target Kubernetes in this case that could be running in a different cloud or on-prem. And one of the core pieces of tech that we've built and partnered with the community to build, really, including Red Hat, has been this project called KIDA, which brings the scale aspect. So when you throw 1,000 executions in an Azure function, we very quickly spin you out to 1,000 container or 1,000 executions behind the scenes. And the reason we're doing that is because we're observing and keeping an eye on the events that are coming in. So KIDA is this open source project that lets you bring that capability really to any container in Kubernetes, functions or not. Something we're really excited with. Now a CNCF sandbox project. We have community calls every 2 weeks or so. Just in short, what I'll mention for what we're doing with KIDA is continuing to add better and more support for other scalars, other trigger types. So today it supports things like Kafka, event hubs, queues, durable functions, to name a few. We're moving forward. We want to make sure that it has support for like Cosmos DB or even HTTP scaling scenarios. So just closing the gap. In fact, maybe a good place to go is if you Google or Bing Azure Functions Kubernetes, it'll drop you on a doc that talks about how you can use KIDA with functions. And at the bottom, there's like a paragraph of, by the way, here's some things you might want to be aware of, either triggers that aren't yet supported or workloads like HTTP that will require a little bit of work. A lot of what we're doing is closing those gaps. And then the other thing I'll mention is that we've been far in our way to do a version 2 release of KIDA that should be rolling out in the next few weeks. It's pretty minor in terms of it's not bringing a bunch of new stuff, but it gives us the chance to make a few underlying changes in the APIs and how you interact with it. and aligned with the major version release, some breaking changes there too, just to continue to improve that. So if you're interested in this space at all, definitely encourage you to participate in that community. It's a really fun project that we're helping sponsor on the side.
Thank you, Jeff. I have one more question here. Does using a Java function have any impact on vCPU and memory duration in comparison to other languages?
Yeah, so I'll answer this one kind of initially, but interested to get other folks' thoughts as well. The short answer would be no. In terms of comparison to other languages, vCPU or memory, we're monitoring how much memory your function is consuming. So it would really just come down to the memory consumption of the Java process with your code in general. I haven't done analysis or looked at analysis recently. I know my team's done some in terms of like, is the footprint of the Java process maybe different from the footprint of the Python process? Maybe, but I think it's fairly minor. And in fact, too, when we're running our service, we're keeping an eye on the overall utilization of an instance so we can continue to scale. And so for the most part, I would say it would be something you don't have to worry about a whole lot. Now, there might be some more intricacies there that I don't want to smooth over, but I think the simple answer would be nothing that I would say, oh yeah, be aware of this with Java that other folks don't need to be aware of. I think the underlying footprint of functions in Java in general on each of those instances is fairly light. And so the bigger concern actually comes to what's the resource considerations of the workload you're running. And if you're trying to write some Java code that's looking to consume 4 gigabytes of memory, yeah, that one's probably going to hit some issues. But just the Java itself, I don't think there's anything there that pops to mind for me, at least.
Okay, we have actually 2 questions regarding GraalVM. You talked about it before. So first one is there any support for GraalVM native images? And the second one is kind of related because it's, is there any support for GraalVM native images, but with Micronauts?
I think we already talked about both earlier. So yes.
So yeah, I think we covered the topic. There is support for, theoretical support for GraalVM native images through a custom handler. Now, our initial support for Azure Function that we released with Micronauts in the first version is targeting pure Java functions. But we are, the next item on our agenda to look at, and we'll be looking at it very soon, I imagine, is to see whether we can get GraalVM native Micronaut images running using a custom handler. And like I said, there is some additional build tooling. I think you would need to delegate some of the work to a CI system like GitHub Actions and so forth, so that we can compute the native image for the Windows platform, so that we can run it and so forth. So that there's some work to do on that front, I think, but it's absolutely seems to be viable given what I've seen in the preview documentation for custom handlers.
And we already reached the end of our Q&A.
Yeah, so thank you, Christopher. So thank you, everybody. So that's our thank you slide, of course. So if you liked that presentation or not, of course, well, we would be very happy to have your review of this session. So for that, you can visit ak.ms/mybuildevals. If you have any questions about today's session, well, you can connect with the 3 of us on Twitter, so Jeff Holland, Julien Dubois, and Graham Rocher. You can also see Christopher and Maud on Twitter if you want to. And by the way, thank you, Jeff, and thank you, Graham, and thank you, Christopher, and thank you, Maud, for this session. If you want more resources, well, first of all, the first thing I put was just a generic link on Azure Functions if you want the official documentation. If you want some specific documentation on Micronauts, there's a blog post that was published a few days ago on the Micronauts website about how Micronauts supports Azure Functions. And last but not least, this is my example of running a Spring Cloud application on Azure Function. So thanks a lot, and well, don't hesitate to contact us on Twitter. Thank you.